We will soon start this webinar in about 30 seconds. So, welcome everyone. Hello. Today we will talk about ACAP, what it is and how it can benefit you. You will learn directly from our expert CEO and CTO, Daniel Falk, and he will guide you through all of the basics of ACAP, showing you what you need to know to create your own innovative applications. But before we start, I would like to share some practical information for you who have joined our webinar today. If you are joining on your phone, the web camera might put itself on the slides. So if you are on your phone, you can just drag and drop the web camera image to make the slides show better. In the black menu bar, you can also find the Q&A button where you can ask your questions. So in the end of this webinar, we will have a Q&A session. So please feel free to write any questions you have during the webinar, and we will answer them in the end. And please also, if you see in the black menu down below, you have a more button, 3 little dots. There you can change the layout. You can have tilde or sidebar, depending on which view you like, if you want the slideshow to be bigger or if you want the Daniel to be bigger. I think that's all the practical information. But before I let Daniel enter the stage, I would like to know some of you here in the audience, how much experience do you have? So I am going to start a little poll here to kick off the day. So how much experience do you have with the Axis camera? And you will probably soon see it on your screen, and you can vote. So how much experience do you have with the Axis cameras? And we see some voting going on here. Yeah. Okay. So I'm showing you the result right now. I use them daily. Amazing. Then you're in the right place. So one more. How much experience do you have with ACAP applications? Should see. Oh, yeah. Here, there's more diversity in the question, in the answers. I will give it some more seconds for you to answer. Yeah, and here the answers were in all diversity. I've created my own ACAP applications. I have never heard about their power. I have heard about their power, but never tried them, sorry. But then you are also in the right place, because Daniel, you are going to take the stage and answer the questions. What is ACAP and how can it benefit you?
Exactly. So thank you for that introduction, Michelle. I will go over a lot of basics about ACAPs today. Maybe not all the basics, because there's a lot of them, but we will dig into a lot of stuff, and with as much as we have time to in 1 hour. So let me just share my screen, and you should hopefully see my slides now. So what we are going to talk about today is how you can get your network cameras to do what you want them to do. And we're talking specifically about the Axis network cameras. And the way we will get our cameras to do what we want them to do is that we will create our own custom ACAP application. So that's an edge application for the camera. So it's really good that we had a good distribution among our viewers from using Axis cameras daily, but haven't used the ACAP applications in them, to people who have already created their own and hopefully want to learn more about this amazing area. So before we dive into this a little bit shortly about me, I started developing embedded code about 2006, so quite a long time ago now. And we will see later in this presentation why embedded development is an important aspect when we talk about ACAPs. In that time, it was small microcontrollers from Microchip, so very different from an Axis camera. But the two biggest challenges there was, first of that, you need to cross-compile your code because it's another architecture than the host, which makes it a little bit more complicated. And also you need to understand the hardware to write as efficient applications as possible. And this is exactly the same challenges that we see with ACAP development for the cameras. So this gives me a lot of relevant knowledge that we will make use of today also in this presentation. In 2016, I started developing my first ACAP application at a small company. We created analytics applications, and then that company got acquired by Axis. So I joined Axis and was there for 5 years, working as a tech lead for the Axis retail optimization and loss prevention suite of ACAPs. And while being at Axis, I saw that there are a lot of use cases that you can solve by using ACAP applications, but not as many companies were actually doing it as I think should do it. And the reason for that was that it was hard to find information, and it was hard to create applications, which make it very costly. So that's what I wanted to change. So what I did was to quit my job at Axis and start the Fixit company, where we focus only on making ACAP application development easy. So why ACAPs? Why should we create ACAP applications for the Axis cameras? One of the reasons to do it is that there are a lot of devices that can run ACAP applications. Axis doesn't only create network cameras. They create all kinds of different devices, from door stations to sirens and modular cameras. And the cameras come in all different kinds of models, from small indoor cameras to explosion protected cameras, and really everything in between it. And almost all of these devices can run ACAP applications, which means that if you know how to write an ACAP application, then you have a lot of different hardware that is robust and durable that you can work with. So we were talking with one customer a while back, and before we introduced ACAPs to them, they had been using a Raspberry Pi, which is a tiny one-chip computer that they put out on the site to get some extra compute. And they said that everyone who works with Raspberry Pis knows that you deploy it, and then it works for 2 weeks, and then it breaks, and you need to go there and reboot it if you're lucky, or you might need to reinstall it. And that doesn't happen with Axis cameras. They are created for security critical situations, so they are really as robust as they can be. And if you create an ACAP application in the right way, then that one will also be as robust as the camera. So one of the reasons that we want to use edge analytics is that we put all the important things as close to each other as possible. So we remove dependencies on parts of the system that might break the functionality. So in this image, we can see that we have one camera, we have one strobe. Both of these can run ACAP applications. They are connected to a router. So with one single cable, the camera will get both network connectivity and power, which means that it's a very simple system to install. And if you now use the ACAP application in the camera to run your analytics based on what the camera is seeing, then that camera will continue to do its analytics as long as it has power from the router. And if you want to affect something, you can do that directly from the ACAP. So the ACAP in the camera can send a signal to the ACAP in the strobe, or it could send a signal directly to the strobe using the network APIs. That now means that you can control a system with a strobe and a camera without other dependencies. And often you want to have some kind of user interface where you can configure things, or where you can view statistics and metrics and historical data, for example. And that you can do in an external computer. That means that this external computer is not part of the critical system. Even if that computer would break down or stop or reboot or lose internet connectivity or connection to the device will still continue to operate. It will continue to analyze the images to aggregate data that you can review later. So that's one of the benefits with using edge analytics directly in the cameras. Some other of the benefits is that you get a seamless installation process. It's really easier to install things with less devices. And in many cases, it might not be possible to install extra hardware or extra computers at a customer site, because they might have limitations on the space available, or it might be safety limitations that you're not allowed to hide it behind a panel, for example. And yeah, as I said, higher robustness and lower maintenance if you have fewer components. You also get lower latency. So if you have real-time control systems, for example, if you control a gate or something like that from the camera, then it would often be too slow to run it through the cloud. So by running it directly on the camera, that will be much faster. And when you expand the system, you just buy a new camera, you install the application, and you're up and running. You don't have increasing cost for cloud services that grows and grows with more cameras. You also don't need to send the video over the network, which means that you can access higher quality video because you don't have the same bandwidth limitations. But there are some possible downsides with edge analytics, and they are higher upfront development costs that we normally see, and that you need to adapt the software to the limitations of the hardware. And this is exactly where Fixit comes into play, because we know these devices inside out, and we have done this process many times before. So we can help you navigate these and help you select the most efficient solutions, and help you create the best possible solution for the lowest possible price. So just a quick look at some different use cases that you can do before we dive into what an ACAP application actually is. So we like to split these use cases into 3 different categories. So we have connectivity, we have decision making, and we have analytics, where connectivity is all about connecting different things in a more native way. So for example, we have direct to cloud, which is popular in VMS solutions, where you want to connect your camera directly to your cloud service without an extra hardware on the site, which means that the camera needs to do the initiative because you can't access it without opening firewalls and things like that that really don't belong in this time that we live in now. So this is one popular use case for ACAP applications. But there might be all kinds of different use cases when you want a camera to integrate natively with the cloud systems that you already have, or the on-site systems that you already have. So for example, in manufacturing industries, you might have a specific protocol that all your sensors are talking, and you want the camera to talk the same protocol. And then we have decision making, which is all about taking decisions or creating actions based on the perception. So for example, this could be to trigger an event, or it could be that you analyze different events and trigger new events based on a combination of different events. Or it can be that you monitor something for a change or a lack of change and then trigger some action based on that. And we will see more in a later slide what kind of actions this can be. And finally, we have analytics, which is about the perception. So it is about actually analyzing the content of the image to understand what is the camera seeing. And this can be split down into deep learning and traditional computer vision. So in deep learning, we have object detection, segmentation, anomaly detection, and much more. We will look more at this in a later slide. And we have traditional computer vision, which is not deep learning based, but is rule based. So for example, here we have barcode and QR code reading. We have OCR, which is optical character recognition, so recognizing and parsing text in the image. Or it could be 3D pose calibration and estimating 3D positions based on views from multiple cameras, for example. So the next step we will go into is what you can do with an ACAP, and we will look at a few different APIs and inputs and outputs. And before that, we will do a poll. So let me start a poll here for you. And so we want to know what do you want to use edge application? Why do you want to use edge applications instead of cloud applications? So here we have a few answers. So we can see that it's a little bit differentiated. We have need lower latency, we have reduced cloud bills, and we have sites without internet connectivity, which seems to be the most important in this, based on these answers. So this aligns quite well with what we have seen. It's a lot of different reasons, and often in different projects, it's completely different reasons, and it's almost always one reason that is the primary driver of that particular use case. So for example, if you don't have internet connectivity, then you really don't have any other option than to run it on the site. And yeah, you don't want to put extra hardware if you can put it in the camera that you have already bought. And reduce cloud bills, also something that we see often, that companies start developing something for the cloud because it is very easy to find information about how to do it in the cloud. And the cloud providers make it very easy to start, and they make it very cheap to start. But then when you start having more and more cameras added to your system and more customers, the cloud bills start exploding in cost, and it just makes it unfeasible, and the company needs to go and migrate to the edge instead. So with edge, you just pay for the hardware when you buy it, and then you use the hardware that you have already paid for. So next section then, we will start looking at how do you install an application, how do you configure an application, what inputs and what outputs can you have to an application. And we will see some examples of different analytics that you can do, different algorithms that you can run in the cameras. So first, installing the application. This is one of the best things about applications for the Axis cameras, that when you build your application, it will produce an .eap file. This is just a normal file that you can distribute to your customers or to your system integrators or to the IT administrators, and they can then install it in the cameras. And if you want to install an application in one single camera, what you will do is to go to the web interface for the camera. You go to the Applications tab, and you have your interface here for installing an application with 2 simple clicks. So the important thing here is to remember that you need to know which application is compatible with which camera, so install the right one. And once it is installed, you can just flip this slider to start the application, and it will run in the background. And depending on how you configure it when you build the application, you can tell if it should run only once or if it should automatically restart whenever the application or whenever the camera restarts. So that's typically what we see for analytics application, for example. If you lose power and the camera restarts, then as soon as the camera starts again, the application should restart. And that's what it will do when it runs as a background service. And of course, the application will continue to run even if you close the browser, because everything runs in the camera. So you don't have any dependencies on the actual computer viewing the interface. So there are also more ways to install an application. This is if you install it in one single camera. Often we see that customers have thousands of cameras that they want to install the same application in, and then this would be very time consuming. So there are a lot of tools for that. We will cover this in the next webinar, which is 1.5 weeks from now. So if you're interested in those more advanced topics, then look at that webinar. So some common questions that we get about ACAP development. First thing is royalty. Customers tend to ask us about, do we need to pay any royalty to Axis if we create an application with the Axis SDK to run in the camera? And no, you don't need to do that. Axis is selling cameras, and they want to sell more cameras. So if people create more applications for the cameras, then it's better for Axis. So that means that you're free to use the Axis SDK to create commercial applications for the cameras. Second question is about licensing. When I have created my application, do I need to have a license in some way to have a customer install it? And you don't need this either. When you build the application, it will produce an EAP file. This EAP file is all you need to install it in the camera. And then there is an optional licensing system that Axis offers for developers to use. And this is very useful if you want to copy protect your application. So for example, if you want to sell your application for a one-time fee, then you want to make sure that even if you send the application file to a customer with 100 cameras, they should just be able to install it in one camera if they have just paid for one camera. And this you can do with the licensing system. So if you want to do this, we can show you how to do it. We also have things on our learning portal if you want to explore it yourself. And there's also an option to cryptographically sign your application that Axis also offers to application developers. So the reason you want to do this is that you want to authenticate, or you want to have authenticity of the application. When a customer installs it, they want to know that it actually is a valid application from you and not from someone else who have modified it or added malicious code to it. And this you can also do. You need to register as a technology integration partner to Axis if you want to validate your own authenticity, since Axis needs to know who you are to use the cryptographical system to validate that. If we create the application for you, then we will sign the application so that the customers can see that it's a known creator that has created the application. And last question is about if you need to register to become start with development of applications for the Axis cameras. And no, you don't need to do this either. Axis is very open with their software development kit and their developer documentation. So you can find all on their website. Michelle will show you later where to find it. And there's also a developer forum that Axis hosts on their GitHub that you can join for free and ask questions. And we have our learning portal where a bit of the content is available for anyone. If you register for free in our e-learning portal, you will see a lot more information. And then we also have some paid courses there that you can take. But to get started, there's nothing you need to do more than download the right tools and read documentation and get hacking away. So now we have created your first application and you need to configure it in some way. So this could be that you need to specify the URL to a cloud server, which it should connect to send data to, or it could be that you need to configure a counting zone for a people counting application or a region of interest for your deep learning, for example. So all these kind of different configuration is typically done through the web interface in the camera. And this is since the camera is a headless system, you don't have any display connected directly to the camera. So the web interface is really the primary interface for interacting with the camera. Or using web APIs, which is on a technical level very similar. And there are essentially two different ways you can do this. You can either create your own user interface with your own web page. An example of this we can see on the right side. So this is an application that is created by Axis, but it's still an ACAP application that hosts its own user interface. On the left side, we see a simpler approach where we make use of the accelerometer interface that already exists in the camera. And this is a simple way where an application can specify which parameters it needs to configure. And the camera will automatically create a user interface for you where you can input parameters. So which one should you use? It depends on what you want to do. For very simple applications, the accelerometer one is often the easiest way to go because it's just a few lines of code and you will have your configuration set up. If you choose to create your own web interface, the benefit with that is that you can customize it in any way you want to. You can use any front-end language you want to. You can visualize statuses, you can visualize the live stream, and so forth. So it's much more flexible, but it also is a lot more work to do since you need to create both the user interface and you also need to manage the actual parameters in the camera. And there are also a few different web interfaces that you can use to create, or different web APIs that you can use to create a web interface in the ACAP. We won't dive into this in this webinar, maybe in a later webinar, but we also have a lot of information available in our learning portal for free where we compare the different options and help you select the right one for you. So, an ACAP application, a plugin package that runs in the background in the camera, and it's running without dependencies. But what does it do? What can you actually use it for? So there are different inputs and outputs that you can use in the application. We just covered a web server that you can use to create your own web interfaces, or you can use it to create web APIs so that other services on other network systems can communicate with your application. We also have events, which we will cover on the next slide. We have logging. There is a built-in system log in the camera that you can log to. So if you just want to log simple text messages and output to the user, then the system log might be a good way to do that. We have audio in the devices that you can use. So you can either produce audio or you can consume audio. And here you need to look a little bit on the particular device that you're using, since not all devices have both microphone and speakers. Especially the cameras might or might not have it, but there are a lot of cameras and a lot of cameras have both microphone and speakers. And we of course have images, considering that it's mainly cameras that we talk about. So you have the video stream that you can consume to do your analytics. And a lot of the cameras have I/O ports. which you can use for either serial communication or to control outputs, digital outputs, or you can use them as digital inputs. And all of these things are typically done using APIs that exist in the SDK. And a lot of them we have examples for, either you can find it on Axis official examples, or you can find information on our Fixed-It e-learning portal. So the event system is one of these inputs and outputs. The event system essentially consists of a message bus that all the Axis devices are equipped with. And here you can either consume or you can produce events with your application. And in the Axis user interface for the camera or for the device, you can configure different rules for how to react on these events, which means that you can connect different features and applications together to create different rules based on the events that they produce. So this is one of the most common things to use in an application. And one benefit with it is that it extends outside the camera. So if your camera is integrated into a VMS system where you can manage the see the video streams, then you can also use this to create rules in the VMS system that are produced from events in the camera. So it's a very portable solution to use. Another way that you can produce output is visually. You can draw overlays on top of a video stream. So this is very typical in deep learning applications. For example, when we do object detection, for example, we want to see what object have we detected. So this might be the primary way your application outputs information if you want to do some kind of augmentation of the video stream. But more frequently, it's a configuration and debug utility that you have an application that is performing some kind of analytics, and you use the visual overlays to see what's actually going on inside the application. So one important thing to say here is that not all cameras support overlay API. It depends on the chipset used in the camera if they support this or not, which is a bit different from overlays that are configured through Vapix, which you can typically do in all the cameras. One of the benefits with using overlays to render graphics is that it's burnt into the video stream itself that the camera already is producing. So you don't need to do any of these analytics or any of this streaming functionality yourself. You get it for free. And if your camera is integrated to a VMS, or if someone is watching an RTSP stream, or if they are recording video, the overlays will still be there. And you can also do much more advanced overlays. So it's not limited only to boxes and text. You can also do any kind of graphics. You can do picture-in-picture, or you can do segmentation masks, or essentially anything you want. Essentially, there are two different ways you can configure your overlay depending on how easy or hard you want to make it for you, where the hard way is essentially unlimited flexibility, while the easier way is very good for text and boxes and lines. So if we look at some analytics use cases that you can do with a camera, then one of them is optical character recognition. So all these ones are traditional computer vision. They are not deep learning based. So optical character recognition is all about understanding text that is in the image. So for example, in the upper case here, we see that we can decode the numbers that are on a parking lot. Or in the lower example, we can see a parcel with text on it, how the camera can automatically decode the text. And doing this is relatively easy. There are libraries that you can do to do this. The thing you need to consider is that the spatial understanding of the text or the contextual understanding can be much harder. So if you don't know exactly what text will be where, then it might be hard to understand, to make sense of the text you read. You can do QR and barcode reading. So we have seen customers that have previously been using infrared barcode readers, which are very expensive, and the only thing they can do is to read barcodes. And then they have switched out to access cameras with a barcode reader, and suddenly they have a much more flexible system that they can use for much more than just decoding the barcode. We have gauge and indicator reading. So this is an open source example from Axis that you can find on their GitHub page. So here you can point the camera at the analog gauge, and you can decode what is the current value it is pointing to. So it's an easy, non-intrusive way to digitalize older equipment. And this is, in this example, we see what is quite typical for traditional computer vision, that it works very good in some specific situations, but it doesn't generalize very well, which means that you should be prepared that you need to do some changes to the code to make it work well in your particular situation. And finally, we have size and area. You can use the camera to estimate how large an object is or how big volume something is. And these are all estimates. If you want really accurate detections, then a camera is probably not the right way to go. But if you already have a camera, or if you want a more flexible solution, then this might be the best way. So essentially what you need to do here is that you need to do some kind of calibration of the scene, which you can often do with a checkboard pattern or some other known spatially known thing that you can map the reality to the image with. And then we have the deep learning based use cases. So here we have starting with classification. Classification is all about putting a label on an image, or in this case, region of interest in an image. So in this case, we have manually specified one parking lot where it is located in the image. And then the deep learning model will classify this particular parking lot or parking space as free or occupied. But you could, of course, have more than 2 different categories for the classification. But with classification, you will not get any spatial information. You don't know where the object is. You just know, is it this thing or is it that thing? So if you need to know where it is, then you should use, for example, bounding boxes. The bounding box will give you a rough area where the object will be inside, and it will also give you the classification of what it is. So bounding boxes is probably one of the most common things we see in deep learning. But if you need more granular localization, then key points might be the way to go, or post estimation, which is just a special case of key point estimation. So here you will, instead of estimating a bounding box where it's somewhere in the bounding box, you will find a particular point on the object, for example, the head of a person, or you might find several points of the object, for example, every joint on a person, so you can see their pose. And finally, we have segmentation. If you need to know every single pixel in the image, what object does it belong to, then it is segmentation that you're looking for. So when it comes to implementing these in the Axis cameras, one thing you should remember is that not all cameras have deep learning accelerators. And if you run this on the CPU, then it will be very slow. So if you do have a camera with a deep learning accelerator, complexity depends a lot on which model architecture you have and what camera accelerator you have. But a little bit simplified, we can say that classification is typically very easy to get running in the camera. Bounding boxes are a little bit harder. Some architectures are relatively easy, some architectures are impossible to get running in the camera. So you have a wide range there. So what we recommend is to use an architecture that is already proven to work in the camera. Key points, a lot in the same as bounding boxes. It might be easy, it might be hard, and also segmentation. There we also have seen very easy cases, we've seen hard cases. And generally we can say that bounding box architectures are typically limited by the operations they use, if the operation is supported in the deep learning accelerator or not. While key points and segmentation is more often limited by the sizes of tensors. So if you have too big tensors, then they might not fit in the DLPU and it will not run in the camera. But this we could talk hours about, so we're not going to cover this more in this webinar. We will hopefully have more webinars about this in the future, and we have a lot in our learning portal. But if you want more direct help, then just contact us and we will help you with your specific use case to make it as easy as possible. And once you have the perception and once you know what is in the image, then you want to act on it in some way. So you want to create some value from the insight. So you want to create some agency for the camera so that the camera can act on its own based on what it has seen. So again, going back to events. Events is a really common way to do this, that you can both consume and produce events. And when you do that, you can configure different rules in the camera. So the user himself can configure what should happen if this particular object is detected, for example, or when this particular event happens. And if you have correctly produced an event in your application, then your application will show up in the list of applications when you look at the different conditions available in the camera's rule engine. You can also do metadata consumption. So you can piggyback on the deep learning models that are already existing in Access Object Analytics, for example. And this is a new beta API that was recently added, which makes it very easy to consume. Earlier, it was much harder to get the information locally on the device. You can do object tracking. So if you have detection from an object and you need to know which object has moved where and where was it before, then you need to do tracking. That is can be a little bit hard to implement from a mathematical perspective, but it's typically not hard to cross-compile for the camera. And finally, we have if this then that, which is just another word for doing some kind of condition-based decisions. So this you would just implement with code, and since you write your application in code, it's really easy to implement all kinds of this logic. So going into the third section. Now we will focus a little bit on how to plan your ACAP project. So we will look a little bit about the challenges of cross-compilation. We will look on the effects of SDK selection, and we will look on should you go to the edge or should you not. So starting with a camera, you have one specific camera. That camera has a specific model name from Axis. So for example, the camera might be named Axis Q1615-LE Mark III. And this name of the camera describes the collection of all the hardware that is in the camera. We won't dive into all the digits and letters in this name now, but essentially they describe different features, and you can find on the Axis webpage what they mean. We also have courses where we cover it from a more developer perspective. But starting from the developer's perspective, we can take a bottom-up approach instead and say that the most important thing we want to know is which architecture the camera is running. So to the right in this table, we can see that the different camera models we have listed here are using ARMv7, MIPS32, ARMv7, ARMv8. And most of the cameras that Axis use today have the ARM architecture, either the V7, which is 32-bit, or the V8, which is 64-bit. And this is the most important thing to know as a developer, because it decides which compiler should you use. Should you compile it or cross-compile it with this compiler or that compiler? And this is where cross-compilation comes into play, that something that is compiled on your computer using your normal compiler, that will be compiled probably for the x86 platform, which means that it will not work in the camera because it's another instruction set. It doesn't understand the binary produced for your computer. So that's why you use the cross compilers that Axis provides in the SDK. And it also means that you will need to build two different applications for the two different types of cameras that are currently used. And if we take one step up from this, we have different system on chips and we have different CPUs. And you need to find out which architecture it is to be able to build your application. And the one way to do this is to use the Axis product selector, where you can look up a particular camera model and you can see which system on chip it is using. So it is always a one-to-one mapping between a camera model and the system on chip. So for example, the Axis Q1615 LE Mark III will always have an ARPX7 chip. And then you have a one-to-one mapping from the chipset to the CPU that is used in the camera. So for example, in this case, the ARPX7 is equipped with an ARM Cortex A9 CPU. It also has a built-in GPU that is used for rendering overlays. And some of the cameras have a DLPU, a deep learning processing unit. Sometimes this is built into the chipset itself, and sometimes it's not. So for example, in this case of the ARPX7, the DLPU is a separate chip that is mounted in the camera's board, which means that there are ARPX7 cameras with DLPUs and there are ARPX7 cameras without DLPUs. While this is different from the ARPX8 cameras, for example, where the DLPU is built directly into the chipset itself. So you know that it's always a DLPU if it is a ARPX8 camera. So all this information you find in the product selector and in the SDK documentation. So second thing is to select the right SDK. I see that we're getting a little bit low on time, so I will need to jump a little bit forward here. But essentially, the important thing to know is that there are 3 different SDKs that are currently supported. And these 3 SDKs is not a direct replacement of the earlier ones. They should be more seen as different alternatives depending on what you want to do. So we will hopefully cover this in a later webinar. We also have a lot of selection guides in our e-learning page. So if you go to learning.fixit.ai, you find much more information about this. So this is really an important step in building your application. Which SDK you select will dictate a lot of things about your final solutions. So you need to make this right from the beginning. So I'm skipping over some slides here about that and going into the next step of the planning, where the key point to see here is that the first time you invest in an ACAP project, it is quite a big investment. There's a lot of new things to learn. and you need to do integrations to all the existing hardware. So for all the existing systems that you are using. So for example, if you're using, if you're creating a machine learning application or a deep learning application, then you need to integrate the training framework in a way that it will work with the Axis cameras, the LPUs. And you will need to integrate it with your data sources that you have in your company and so forth. But after you have done this, all this infrastructure is already built up, which means that if you want to create a second deep learning application that does something totally different, then that project will be much faster because you already have all the integrations needed. So in the best case, maybe you just need to repoint the training to another data set, retrain it, and deploy it to a new application, and you have a second application with almost no effort at all. In some cases, you might need to do some changes in the logic to how the application acts on the data from the model. That is typically also an easy thing to do. So just make a copy of your application, change these things, and now you have two different applications. And it's also a lot of in-house knowledge that you build in your first project. You educate everyone in the organization about how to install ACAPs, how to manage them, how to deploy them, and so forth. And all these things are also reusable after the first investment. So it's really a platform that you should be able to grow on. So when should you go to the edge? If there are significant benefits with edge, if you need a robust system, if you need low latency, if you have bandwidth limitations, then of course you should go to the edge. If scale favors fixed cost over variable cost, then it's a good time to go to the edge because you have a slightly higher upfront development cost, but once you deploy it, you don't pay anything if you already have the cameras, which you would need for cloud-based solutions anyway. And finally, if you have policy or legislations that require local processing, then edge is also very good because you don't need to stream a video or images anywhere. You keep that local in the camera where it's safe, and you just stream the metadata over the network. So a little bit quickly then to wrap up this webinar, we will focus on how Fixed-it can help you in your ACAP development project. So right now we have talked a lot about what Axis is offering. And I said in the beginning that it isn't that many companies that are creating applications for Axis cameras because it is a little bit more complex than it needs to be, or at least it used to be that. So that's the offering that we have provided for the last years to make it as easy as possible to create applications. And we have really seen that we have enabled a lot of new applications that wasn't possible before because now customers can use our services to make it much faster, cheaper, more robust, and easier to get started with. So we essentially offer everything that is needed to create ACAP applications that is building on top of the offering that Axis is providing. So we have education for developing ACAPs, both in-person training and our e-learning portal. We have consultation and implementation. So regardless if you need help implementing your own application, if you need help solving an issue you have, or if you want us to implement the full solution for you and maintain the solution for you, then we can do that. And we have tools that make it easier to work with applications. So tools that complement the tools from Axis and makes it a more easy to use system and make it easy to manage application, monitor applications, deploy applications, create applications, build applications, use CI/CD for automated testing, and all these kinds of things. We try to create tools that makes the hard things easier. So a consulting project typically looks like that you book a free consultation meeting with us or an introduction meeting with us where we discuss what challenges or what opportunities do you have. And based on this, we create a recommended system design for the ACAP application. And we create a work breakdown for the project together with cost estimates. And based on this, we will start the project if you think everything looks good. Yeah, that's essentially those parts. And after that, we just do implementation. We empower you with all the information needed and so forth. And we do all this for a strategic partnership. We focus long-term with you. As we said, the first investment is only the start. So after that, we help you with all the new innovation, ideation, what more things can you move to the edge. And we have been through the process of productization a lot of times before. So we have good processes for ensuring quality. So we will talk more about this in a later webinar. So essentially what you get is a lot more than our time. We have our own camera lab that we use to develop and test your application if you don't have the cameras yourself. We use our tools, we use our infrastructure, we use our reusable projects and so forth. And we have a proven process. So next step. Just contact us, book a free meeting, sign up for our tools, schedule a teacher-led team training to give you the confidence needed to start a project, or request advice. We are here to help you. So thank you. Back to you, Michelle.
Thank you so much, Daniel, and for all that knowledgeable information. I will talk to you in the audience now. So now you have been listening to what Fixit can offer and what ACAP can offer. So I'm going to start a poll. So what services are you interested in when it comes to this topic? See. Yeah, perfect. Thank you so much for answering. I'm gonna close the polling in a couple of seconds. Yep, thank you so much. I am actually gonna take over the screen here because there. So you have been listening to Daniel, our CTO and CTO, talk about ACAPs now for almost an hour. But where should you start if you want to get started? So the first place is the access documentation. On this page, you can find documentation, and you can also find API references. We especially recommend using this and the native SDK API and have this bookmarked on your web browser to have it easy accessible. The second place we recommend is the ACAP native SDK examples here in GitHub. Here you can find an example repository for Docker-based applications and a lot of different examples. We do think, however, that some examples are missing here in this repository. So Fixit, we have our own repository as well with a few different examples. We have, for example, a pre-installed script, parameter handler, and our Fixit application.
I think the screen is frozen. We can just say that both the Access example are available at Access GitHub page, and our examples are available at our GitHub page. Fixit AI on GitHub. So
sorry. Good that you're stopping me here. So here I was in the beginning. I scrolled down, went to the documentation, and here you have the SDK documentation, the API, the native SDK API. So sorry for that, technical issues. And here we have access GitHub, the ACAP native SDK examples. And here we have the Fixit access ACAP guides. So yeah, now we're back. And we also recommend using our e-learning platform, of course, as Daniel talked about. And here is a lot of free resource learning. And there's also some that's for our customers. And I think if someone here in the audience is interested in contacting you, Daniel, to learn more, what should they do?
Yes, so they can contact me either via email. We have on our website, fixit.ai, they can fill out the form, or they can just send me an email directly on daniel.falk.1@fixit.ai, or send us an email at info@fixit.ai. I'm also very active on LinkedIn, so I produce a lot of content there, both on my own LinkedIn and my own fun ACAP projects, and also on the Fixit.ai LinkedIn page, or Fixit Consulting LinkedIn page. So I recommend you to follow at least our company page. And yeah, I think those are the two primary ways to contact me. We also have a YouTube page where you can find a lot of videos about ACAPs.
Perfect. Please reach out. I also have some questions here in the Q&A, so I'm gonna read and excuse us for taking some more minutes. If I develop an application in Python making noise detection according to decibel levels, how can I install it and run it on Axis P3265 V-Dome camera? Can I use ACAP native SDK? Or in the case of ACAP Vision SDK, how can I install and control the plugin?
Yes, so you can use the native SDK. You can also use the computer vision SDK. One of the things to be aware of in the computer vision SDK is that a lot of the APIs in the SDK are not available in the computer vision SDK. So for example, for audio, it might be more challenging to get the audio from a computer vision based application, especially if you do it in Python, for example. So the native one would probably be a good choice. Native SDK also makes it easier to actually deploy your solution once you are ready with it, because that's one of the things that make the computer vision SDK more complementary to the native SDK. That the thing I showed with installing applications from the UI, you can't do that directly with a computer vision SDK application, because that just produces a Docker file, which you will need to get to the camera and start in some way. And if you don't have any extra functionality or an extra system that does it for you, then you probably want to pair that up with a native application that will install the Docker-based application for you. But yeah, especially look at the audio API to make sure that you can actually access the audio in an easy way, is my recommendation.
Thank you. I hope that answered the question. I do have one more question. What access devices can run ACAPs, and how do I find out if they can run them?
Yes, so most access devices can run ACAPs, not all of them. If you look at cameras, I would say that almost all of the cameras that are produced today can run ACAP applications, except for the body-worn cameras, which currently can't do it, and maybe some other cameras. But the way to find out is, the easiest way is to go to the product selector. So just search for Axis product selector, and you will find a very nice tool where you can search for a specific camera model, and you will find all the different technical information that you need about it. And one thing there will be Axis camera application platform, and it says yes or no. If it says yes, then you can run ACAP applications. But then unfortunately, it's a little bit more complex than that, because that it can run applications doesn't mean that it can run your application. So that's probably more for another webinar, because it depends a lot on which SDK did you use, and what libraries are you using, what interfaces. For example, as we said about the overlay, it doesn't exist in all cameras. So it's a lot of complexity in figuring out what cameras will actually be compatible with your applications. And that's, of course, one of the things that we help customers a lot. So if that's a problem, just reach out to us, and we can quickly sit down with you and help you figure out which cameras will be compatible with your application, or how you should write the application so it is compatible with some particular cameras that you need to support.
Perfect. Thank you so much, Daniel. And thank you so much for the presentation. And thank you in the audience for listening to us and being interested in ACAP and interested in Fixit as well. So yeah.
Thank you, everyone. Bye.
Have a good evening. Bye.